I'm Dean Bushmiller with Expanding Security, and this is Network Architecture Principles and Practices. Use of this recording by AI is strictly forbidden. I know what you're saying. You're saying, Dean, there's a lot of really good network architects out there. What do you know about network architecture? Well, we want to refocus what we're actually doing here. Not to say that Dean knows everything about network architecture, because I don't. I'm a security guy, and I'm usually talking to security people right here. So what do security people need to know about network architecture? That's kind of the key to what we're doing here. And when we start off, when we look at our core architecture principles, if we do this well and we understand it well, there's going to be fewer 3 a.m. emergency calls. You went, Dean, that's the networking people's problem. It's not the security people. Because they're going to blame you. So we want to make sure that it's easy to troubleshoot the issues instead of guessing which custom configuration broke the system, and that we can say, no, here is our network configuration for this. I want us to be able to shift our daily routine from firefighting to self-healing and well-segmented networks. That requires that we understand the core. So what are the core network assets that are out there? Well, it's the devices, and those devices could be virtual or they could be physical. That means routers, switches, load balancers, and there's a whole host of other things, but those are the major three that we're talking about. Controls have to be integrated into those things. They include things like encryption, firewalls, authentication, authorization, and auditing, amongst the other things that are in there. We'll dig into the deep details of that later on. We're going to reduce our risk overall doing things like performing audit inspections. We want to make sure that everything is working before the auditors show up, tracking any kind of event logs, and updating software definitions. When we switch to the functionality here, we're talking about component requirements. That's segmentation, redundancy, and defense. Those are the basics of the component requirements. In our implementations, we want to do good standardization, privilege restriction, centralization, and as much automation as we can actually stand. The protocols that we're going to talk about from a functionality standpoint are layer 2 protocols. There could be many of them there. Our layer 3 protocols, most of the time people talk about the routed protocols, but there are routing protocols that we must protect, as well as the routed protocols. On top of all that is the application. And we're going to wave our hands at this point and say application isn't part of this, because this is network architecture. And we say we have to include all of the things for the types of applications that we're dealing with, but we're going to kind of shove that to the side at this point. For deployment at the core level, we look at our assessment of evaluating the infrastructure states. What different states does it transition from? In our design, we look at the architecture blueprints. We may even create them. Usually a lot of times we have what's called a brownfield, where we come in and say somebody's already got this stuff up inside the rack and we have to figure out what it actually is. For execution, we're going to do staged rollout sequences, connect system interfaces correctly, that's between different interfaces, and then we've got to tell everybody how this actually gets done. Ultimately, in our deployment, we want to verify that that deployment actually worked well, and that means that we go back and audit the system's compliance to the standard that we have set up. There are going to be certain impacts that are going to be felt by that. Understanding the impacts ensures that upgrades don't ruin our weekend. I want you to be able to know how to structure the log retention and event data for the next audit. Remember, this is both the network people and the security people. So if we look at the impacts on our process, it's going to be things like altering the management task, updating device settings, and recording the event data. For our impacts on our requirements, that's going to include things like matching the system standards, making sure that all of our wiring is done to the A standard, to the B standard if we're doing Ethernet. We have to be able to move the application workloads around, and that, we've got a lot of virtualization out there where we move workloads from one to another, and we've got this network attached storage behind it. There's going to be some serious impact on our network there. We've got to be ready for that. We have to schedule the service windows. Today, our service windows tend to be, well, basically no downtime at all, so we have to make sure that we're fully redundant. We have to ensure that those systems are fully redundant and fully up, and when we switch from one application to another, or one set of servers to another, or one network attached storage to another, we have to make sure that that feels almost seamless to the customer. We have to survive any kind of component failures in there. That means power problems, networking problems. If you've ever looked at the back of a virtualized environment, it's not just one network card coming out of the back of that. It's at least 3 network cards coming out of the back of that, or 3 network interfaces coming out of the back, sometimes as many as 6. Any kind of log evidence that we have in a virtual environment needs to be transmitted to the physical environment and off of those particular machines. Now, switching gears to engineering, that means we're going to treat everything. Well, we're going to treat everything as infrastructure as code, which will end up making our deployments faster and easier and reversible if something goes wrong. It also means that we're complete in the entire loop on the lifecycle management of all the engineering. So we have to align with the baseline goals of our organization, review the architecture models that work for us. Today, probably that's going to be core distribution and access. We're going to lay out our architectures like that, but core distribution and access, adding in virtualization and then adding in cloud inside of that, that's going to change that architectural model pretty quickly and pretty significantly. And we have to include how the architects of the cloud infrastructure work with that. We're going to deploy code updates to the actual devices and also to our control plane for a lot of our devices that are out there. Those systems have to be monitored for their behavior in the engineering. And when we're getting rid of any kind of disk that we actually have, and yes, we do have memory and disk on these devices, we have to sanitize that storage, and that gives us a total life cycle management on all of this. Lastly, when we talk about governance here, we need to speak the language of governance or speak the language of business, and we have to be able to map that performance data to the actual activities of the devices themselves, so that leadership actually understands. I want to get a clear line from the corporate goals down to my daily tasks that ensure my work that I'm doing is visibly aligned with what the company values most. I have to be ready for that, and that means that I'm going to have to understand what the performance indicators of this organization are. Knowing from a networking standpoint, it usually centers around availability, latency, and throughput, but then the security on top of that is going to change those things. We need to look at our business impacts. That includes the budget allocations or deallocation in a lot of cases, and the expense reductions. How can we get more? How can we do more with less when it comes to our actual equipment and not our people? When we look at our governance activities, they're going to include things like planning the organization's direction, managing department workflows, seeing how that works, especially when we're talking about going across network attached storage from location to location, and executing the process task. I'm security, they're network, but we are the team in this case. We have to be able to enable creations of networks that adapt to the changing business and security requirements, full stop. That's what our goal is. So I hope you'll join me for the entire presentation. Network architecture from an AI standpoint. Where do we intersect with this? Well, network architecture is shifting because of AI. From a configuration standpoint, in the past, what we used to do is have the configuration script that we used to play. But now what we're doing is we're doing things called intent translations. I'll explain that in a minute. On our operations side, in the past, what we did was we did troubleshooting. We want to steer away from that. So what we're doing is maintenance forecasting in a lot of cases. For telemetry, capturing the data of the system as it's running. In the past, what we did is the polling, your SNMP polling. You would always do that. And now what we're doing is we're streaming data from that device. And this usually means that we're separating the data plane from the control plane. Where we see a lot of AI being injected into the network is in what's called intent-based networking. And we need to dig a little bit deeper here and talk about how this continuous loop is designed for intent-based networking. We start with the translation of this. You've done a chatbot before and you say, hey, I want to know the answer to this question, and you didn't quite type it right or you misspelled things. Well, that translation takes that human readable command, even if it's spelled wrong, and translates that into a network policy. In these cases, what I look for in my tools is for them to confirm this and say, did you mean, something to that effect? Or here's the output that I'm going to push against them. That means that I still have to understand the network. I still have to understand the security aspects of that networking configuration that I'm going to push down there. If I don't know that stuff and it creates something that's a network-wide policy and I haven't approved it and said, yes, this is what we actually meant, our intention at that point, we're going to be in a lot of trouble. We have to activate that. We've got to deploy that to the devices. So we have a centralized controller that pushes all the relevant hardware infrastructure information. It pushes it down. It pushes the configurations, the routing tables, and the security policy to those devices. But we've got to close this loop, and that means we need to go to assurance. So we continuously monitor the network telemetry, and we look for deviation detection. And when we have deviation detection, it directs remediation automatically. We don't go, it doesn't come to us and go, hey, Dean, you got to fix this thing and it isn't working. No, it doesn't do that. It sees this is a deviation because it's looking at the telemetry. It's looking at all this stuff all the time. And all of a sudden the routing update changes. It goes, no, we can't do that. We're going to go ahead and realign that with the stated goal. That's intent-based networking. That's the major focus of AI for network architecture at this point. We also have to look at the framework specifications that are rolling out to us today. For augmentation, we have things like stacked layers. That's the AI agent integration. We have controllers that we're working with that coordinate that execution. The automation includes things like the loops that we talked about previously, but that telemetry analysis is something new that we have to focus in on because it is now streaming information. We need to create pipelines for model distribution, and I don't mean AI models, but model distribution of networking architecture. There is going to be a certain amount of disaggregation where we take the hardware and decouple it from the software. That's that data and that control plane, which we're getting a little bit more into networking on that side. We'll leave that for a little bit. At the industry level, where are we seeing AI and network architecture intersecting? Well, the IETF has come out with NMRG and AllNet Ops, and the ITU has come out with the Y3172. These are not standards at this point. They've dipped a big toe, probably a whole foot into the pool of AI at this point. Be looking at those evolving standards as they come to you.